Okay, let us just continue with our discussion where we have left. In a illustration, a block is given like this, and there is a force applied to the block. The weight of the block is acting downward, and this height is A. This is basically a cube, so even this is also A. Now this surface is a rough surface, so there is a friction developed in this direction, and they have asked you that what is the value of mu, how much it should be, such that see this block can slide, it can topple also. What do I mean by sliding? If the block moves, that is sliding. The block will move if it is more than the frictional force. Now this force F is towards right. Frictional force. What is frictional force? Frictional force is mu times normal reaction, which is nothing but mu times mg. Right? So frictional force is acting towards right. So we have to find this value of mu, possible values of mu. So let us say if F is more than mu mg, what will happen? The block will slide. Okay. Now let us see the condition for toppling also. If you see the condition for toppling, if at all any toppling possible, toppling मतलब पलटी मारना, it can happen about this point x. So take moment about this point x. So you have a moment because of this force, which is F into A. So F into A is one moment you have. And what is the sense? The sense is like this. It is clockwise. So which is preventing it from getting toppled? This weight, which is creating a counter. It is creating a counterclockwise moment. And what is that moment? W into A by 2. Okay. So W means mg only. Mg into A by 2. Okay. So this is the anti-clockwise moment, and this is the clockwise moment. If this is more than this, then there is a possibility that this will get toppled. ये ऐसे पलटी मार देगा अगर ये ज्यादा हो गया. अगर ये दोनों equal हैं, there will be no toppling. If this is more than this, then you get a condition that it may get toppled. So you cancel A. F should be more than mg by 2. Okay. So if you consider this as equation 1, you consider this as equation 2, F should be more than mu mg, F should be more than mg by 2. So let us take a condition that this value can be 10, this can be 20, F can be 50. 50 is greater than 10 and 50 is greater than 20 also. What happens if this value is greater than this value? If you satisfy this condition, let us say, if you say F is 50, this value is 20 and this value is 10. I am just taking an example. That means this value is more than this value. If F is more than this, it will topple. If F is more than this, it will slide. So combining 1 and 2, if mu mg is greater than mg by 2, it will slide before toppling. It will slide before toppling. Okay? So that means if you cancel these two, mu should be greater than 1 by 2. If mu value is 0.6, 0.7 like that, you get a condition that this block will slide. Okay? So this is the one illustration. Okay. So while discussing this question, we have got two conditions, no? I think F is greater than F. So I said that f is greater than mu mg, and for another situation f should be greater than mg by 2. I think I have done a small, just a small correction I want to tell. See, this is the condition for sliding, and this is the condition for toppling. Okay, if mu mg is less than mg by 2, see f is greater than both this value and this value also. If mu mg is less than mg by 2, it will, just make this correction, it will slide before toppling. इसका बस यही मतलब है, अगर मान लो ये 10 है और ये 20 है, मान लो f greater than 10, मान लो f का वैल्यू 15 है, 15 is greater than 10 but 15 is less than 20, so it will slide. Suppose I take f value 15 is greater than 10, will it slide? It will slide. 15 is greater than 20, no, it won't slide, it won't topple, it won't topple, in simple language. So if mu mg is less than mg by 2, it will slide before toppling. Suppose mu mg means what? Mu less than 1 by 2, it will slide. Suppose mu mg is more than 1 by 2, so mg cancel, mu is greater than 1 by 2, then it will topple. This is the concept. I think in the previous discussion I just little bit, okay, understand this. So there are two values, you have to check whether it will slide or topple. If f is equal to 100 here, it will directly topple. If f is equal to 15, it will slide before toppling. If you keep on increasing f, after some time it will topple. So this is the point. In continuing the discussion, you can do one more of this type. This is angle theta. This is some cylinder kept over here. The cylinder mass is m. So mg will be acting downward. This is theta. So this is mg cos theta. This is mg sin theta. Right? So this is the normal reaction. And we have to check when it will topple and when it will slide. Let us say the cylinder height is given as h. So if it is trying to slide down, the frictional force will act in the upward direction. Okay? And what is frictional force? Frictional force is mu times n. It is mu times mg cos theta. Now here this is my x and this is my y. Alright? So m is equal to mg cos theta. So f is equal to mu mg cos theta. This is the value of f. Now look here. If mg sin theta is greater than f, it will slide downward. Right? It will slide downward. That means mg sin theta should be greater than mu mg cos theta. So cancel out mg. You get, bring cos theta this side. You get tan theta more than mu. You get the condition that it will slide downward. Now let us say it is trying to topple above this point. It is, I just draw the exaggerated diagram. It is trying to topple above this point. Now this height is h, and if I consider this as a center line, this is my r. So here there is a, we need to find out the torque. So there will be a torque because of two forces here. Okay, which forces? See, there is one force which is in this direction, which is mg sin theta. Okay, now mg sin theta, it is acting like this. So where it, mg sin theta, where it will act? It will act in the CG of the cylinder. So what will be the torque? It will be mg sin theta into h by 2. Okay, mg sin theta is acting here. It won't be acting here, it will be acting in this CG. So mg sin theta into h by 2, it is trying to create a clockwise and anti-clockwise torque about this point. Who is balancing it? So there is a force in this direction which is mg cos theta. It is trying to balance it with a anti-clockwise torque. So here, if this is more than mu mg cos theta into what is the distance? This is the r. This is the force. Force multiplied by perpendicular distance. This is r. Okay, cancel out mg. Here what you are getting? You are getting tan theta. Bring cos theta this side. So tan theta into h by 2 is greater than r, or tan theta must be greater than 2r by h. You got two conditions here. This is for the sliding. This is for the toppling. This is for the toppling. So, like what we have done here. Here, if suppose mu value is less than 2r by h, it will slide before toppling. Okay. If mu value is less than 2r by h, it will slide before toppling. If mu is more than 2r by h, it will topple before slide. So we have to frame equations and come to a conclusion in which condition it will topple, in which condition it will slide. So this is the approach. Okay then? So see you in next class. Take care.